This episode is sponsored by my Fall Fast Track, the only 6-week distance mastermind course to help you profit from the private market using performance testing. Enrollment starts on August 1st. Find out more at homeperformance.training. Welcome to the Building Performance Podcast from the Building Performance Workshop. I'm Corbett Lunsford. Today we're talking about performance-based building and retrofits with Ken Levenson, who is the founding partner of 475 High Performance Building Supply and the president of New York Passive House and the co-president of the North American Passive House Network. Ken, that's a mouthful. Thanks so much for being on the show.
Thank you, Corbett. Very good to be here.
You're a busy guy. And it seems like the 475 building supply thing is what I'm going to talk about. High performance, you put that in the name. What exactly is your mission?
Yes, so we wanted to identify what we were doing very clearly with the high performance end of the building, the construction industry spectrum, if you will, and really specifically identifying with passive house construction. So the 475 is actually a reference to the passive house annual heat energy demand requirement to be a passive house, 4.75 kilobTUs per square foot per year. And so that's a very inside baseball term. To be sure, and even folks that spend a lot of time in the passive house world will be the last to realize that it's there. But regardless, the 475 is tying, our sort of DNA to passive house and low energy building, and high performance really being the more public face of that. We don't work just with passive houses, and we're looking for a much broader spectrum of building construction and retrofit that can meet high performance standards.
So the big box home improvement stores weren't doing it for you?
No, actually what happened was, so I'm an architect by training and had an architecture firm for a number of years. And in 2008, I was introduced to the passive house concept, bumped into it online, took the training as soon as I could, and started to work very hard to convince clients to do passive house projects. And was successful in getting a few off the ground. And in working on these passive house projects, we realized that the material selection for what is required to really have a low energy building robustly built wasn't readily available, and the building supply industry wasn't really that interested in it. The knowledge base, the technical knowledge just was not there to any apparent degree. And so we saw an opportunity as an architect working that I knew that these products existed in Europe. They've been around for many, many years. There's a lot of knowledge around the products. And so Floris Keverling-Bussmann, my partner, and myself, Floris was doing some blower doors and technical advising around the passive house projects. We decided to do a startup and start our company. And it was in seeing this, basically this hole in the marketplace, that we decided to fill. And that we were really starting out as, seeing ourselves as our own customers. And that's who we were initially going after.
So when I go to Europe, I notice that the windows are all amazing. They're like submarine windows, and everything is so cool and everything. I think that a big part of that is that normal people in Europe get how this stuff works, right? They are used to it. They know that this exists. Contractors, tuck in their shirts, and they're very professional and everything when I'm sure that it's different in different parts of Europe. But how do we get normal people here? Because, of course, we still have to ship all this stuff all the way across the ocean. Why aren't we manufacturing this stuff here? And how do you suggest that we start selling this to normal people so that there is more demand for your products?
Right. Well, so I think there is a certain amount of truth to what you're saying about the European tradition, but there's also a certain mythology about it. Certainly the trades and craftsmen are well trained, and there's a high level of quality in the craftsmanship in construction in general, particularly in places like Germany and Austria and Switzerland. But that doesn't necessarily translate over into low energy building or high performance building for that matter. They certainly suffered from a lot of the things that we suffer from in discomfort and high energy usage traditionally with these buildings. They may be built to last a long time, but they're still pretty energy inefficient traditionally. And as well, if you move outside of Germany and those areas to Brussels, for example, they had very typically poor building stock and really suffered a lot from construction quality that we may see in the United States more typically. So it gives us hope that a place like Brussels, which 7 years ago didn't have any passive house construction or high performance construction to speak of, as of January of this year has mandated passive house construction for all commercial, institutional, residential, public, private buildings. They were able to transition their construction market to be able to do that. From the consumer end, it's very hard to see how it can ramp up fast by word of mouth. Certainly when people are in these buildings, high performance passive house buildings, they feel the comfort, they feel the quality of the indoor environment, and they understand the low energy bills that are associated with that. And oftentimes they'll want one. It kind of spoils you, and you determine that, well, this is the way we should be living. Why should I settle for anything less? So there's a lot of activity around doing open houses and getting people into these buildings and whatnot. That's hard to do, though, at any kind of scale at this point. And
we need more virtual reality. That's what this is all for.
Yeah, absolutely. I mean, I think what we need are passive house hotels. And if we could get somebody to build a passive house hotel in every major city across the U.S. and running people through that, that would be one way to scale the experience and do it. Certainly where the passive house hotels do exist in Europe, and there's one in Shanghai, China now, it has a great effect on the people that stay there. We're selling, in terms of the 475 and the business and trying to grow the high performance market and to try to grow the market that we're selling into, we are really focusing on comfort drivers, resilience, safety, air quality, as well as the economics. Trying to make it a whole package of benefits. One thing I think that needs to happen, and we see it happening, and what we're really trying to participate in as part of our mission, is the normalization of these types of buildings, that they're not looked at as one-off super special things. And part of that normalization is having choices in the marketplace, and not having it be, it's just that one person, it's that one window, it's that one component, and there's one way to do it. Like fashion, hairstyles, food, anything, there's a lot of different ways to make something great that people are going to love and want to buy and be part of. And, low energy passive house buildings have to be part of that. And that sort of phenomenon of diversity of experience. One of the things in bringing over these components, we're really trying to multiply the choices that are available. And we're encouraged by the ecosystem in general. I think what needs to happen in windows in particular, now we have probably over a dozen choices of window manufacturers. There are now 3, I believe, certified windows made in the U.S. There are a couple of windows certified that are made in China. The options are multiplying fast, and that's one of the key components. Other key components of the construction, the ventilation, there are more and more options becoming available for high-performance construction. Mm-hmm. We were very happy as a company to be able to bring into the U.S. One particular ventilation solution that had not been on the market previously, decentralized through-wall, high-efficiency heat recovery ventilation system. So where you're putting this machine through a sleeve, through your wall to the exterior, it doesn't require ducting through the building, doesn't require commissioning, it doesn't require huge investment of labor and time and disruption to the building, particularly for retrofits, and gives you very high quality, energy efficient ventilation. The multiplying of the possibilities and the multiplying of the project types. Beyond that, it's a bit frustrating, to be totally honest. What's going to need to happen is the codes changing. And it's discouraging on the one hand, but on the other hand, it's we're excited by what's happening with the 3ACH50 code requirement rolling out now, being adopted by many states, and 3ACH50 as an air tightness metric is very far away from Passive House, but it's tight enough that people have to think about it, and they need to plan a little bit for it. It's the contractors, the homeowners, the building owners can't just basically ignore it and say, "Oh yeah, we're doing something tight," and
not be specific about it.
Right, and not be specific about it, and not make conscious decisions about the materials that they're using, about the connections, the details that they're making, how they're sequencing things, how they're putting things together.
So here's my question. From the materials angle, what I always get asked, what product will make my building high performance? And my thing is always, don't ever lean on a product. And the more smart and amazing a product is, generally, the more dumb you act when you install it. You're just not going to do as good a job because you assume that the thing is going to do its own. Spray foam is a perfect example. Everybody thinks, oh, it's going to be amazing, right? And of course, you have to put it in the right way. And that's a whole other conversation, which we have had on this show. So my question to you is, how do you couch the fact that you're selling these amazing products and make sure that the people who are buying them understand that they're going to have to use special methods and check themselves and install it the right way? Are you part of that conversation? Do they ask you?
No, absolutely. And it's a two-sided thing in a way. On the one hand, we're trying to make things as dumb as possible in the best possible use of that term, to simplify, to really optimize the chances of success. And so, you spent a good deal of money on a really high-performance window. It's a rather simple thing, not that complicated, but you need to install that window in the wall properly to get the full benefit of the window that you bought. Now, we don't sell that window, but what we do sell are the connections of that you make between the window as a system and your other control layers in the assembly. So we spend, and what we've found is it's really in the connections where things will succeed or fall apart, right? So the joints between the floor and the wall, the penetrations through the walls and the floors and the roof, and the joint between the walls and the roof, classic problems in all buildings. And so we bring solutions to those conditions with products, and we spend a lot of time doing education. So we try to simplify it on the one hand, and then on the other hand, while it's not rocket science, it requires a certain intention to do something properly, and we try to really, through a number of different platforms, provide a lot of education, specifically from like manuals and instructional videos to generally in our blog, which is very heavy in building science, we just issued our second ebook, which folks can download for free, on iJoist Outrigger construction. And we previously produced an ebook that's also free for download on high-performance historic masonry retrofits. So through a combination, and then we also have CAD drawings that we've developed that architects and engineers, builders can download, copy, paste, modify them, do whatever they want, but at least they're starting with something that has all the components in it to make a completely integrated system, and in its own way as simplified as we think it could be. And then folks can change it. It's still, when you're dealing with high performance at the level of execution, homeowners could do it, but really it's a professional's game, and the training involved is to be taken quite seriously. Again, it's not rocket science, but just having been through the class for that one day and learning a few basic means and methods can really transform the chances for success.
I think in my professional work, most of my time is given to solving the problems that are built into a building by the combination of certain materials or appliances or assemblies or whatever that are, right? This wall and that range hood and that water heater are not going to agree with each other. They're going to have side effects, right? They're going to start interacting. Do you think, let's play future land for a minute, 100 years down the road.
Right.
Since you think so much about materials, do you think it's possible that we won't need a specialist to come in and do that anymore because we will have foolproofed all of the products so that they will not have interactions that are detrimental?
Yeah, no, we won't foolproof anything. I think. I'm sorry to say.
I was going to get a rest in 100 years.
I think certain things will be simpler, and without a doubt, and we see the progression of that, but at the same time, new things are being invented, and there's always this diversity of material and experience. We like to say that there's many ways to skin a cat and do something successfully, and oftentimes it really depends on what the contractor is comfortable with, and the tools that they're bringing to it and experiences. And so we're very cognizant of that in our experience as working on projects as architects and being on job sites. And one of the things that we like to do as a company as part of this integration and education is to get onto the job site, not only look at the details with the architects and the builders beforehand, but on the job site and help work through issues. And make sure that all those compatibility things are dealt with successfully. Just the simplest thing between a different adhesive tape and a membrane or a piece of sheathing or a piece of masonry in different conditions, weather conditions, and it's a system. It's a system, yeah, and it's kind of like it's kind of like a menu in cooking. It's all the same ingredients have always been there, and there are some new ingredients that come along, but it's still that chemistry. You can't get around it.
Yeah.
You need to do it properly. Follow the cookbook.
Let's talk about awesome ingredients for a second. One of the most exciting products that I know you guys deal in quite a bit is membranes from Europe that are smart enough to change the way that they're put together. Can you describe what's going on with that technology?
Sure. So we have a product called Intello, which is a smart membrane, a vapor variable membrane. It's an interior. In a cold climate, you want to have vapor control inboard of your insulation to control the moisture in your insulated assembly and prevent moisture from condensing and creating mold and moisture problems. The Intello membrane, in its intelligence, is reacting to the moisture levels around it. In the wintertime, it's relatively dry around the membrane. Even if you're in a bathroom and you have intermittent showers or a kitchen with boiling water intermittently, it's still in the enclosure, generally speaking, dry around the membrane. The vapor drive is going outward in the wintertime from the interior space to the drier exterior space, exterior environment. And at that time, the membrane is relatively vapor closed and is a vapor retarder. And so it's preventing the humid air from the inside conditioned space from entering the insulated enclosure and preventing that moist air from the possibility of condensing on the cold surfaces.
And just to clarify, we've already taken care of the air sealing, so there's not air going through the wall.
Right. The Intello is also airtight.
Okay.
And so it's airtight. So we have air tightness and vapor control on the inboard side of the insulation with the Intello. And so we're quite vapor closed in the wintertime. As the summertime comes and the vapor drive now switches from the outside and the hot and humid air wants to move inward through the assembly to the interior space, which is often now air conditioned, with central air conditioning sort of making it more robust vapor drive. The Intello, as the moisture levels rise around it, will molecularly open and become more vapor permeable, up over 13 perms, and it waits until the moisture levels rise enough to be heading towards a danger zone, because you don't want the permeability to open too soon. It can cause it can cause issues, but it does open, and so the moisture, if there is moisture building up in the assembly, it can dry inward. Consequently, what happens is that you're preventing wetting of the enclosure in the wintertime, and you're allowing drying of the enclosure in the summertime. You're building what we would call, the drying reserves of the enclosure. A lot of, as we're doing high performance buildings, we're going to greater air tightness, we're going to greater insulation levels. As we're going to greater insulation levels, we have greater potential for condensation issues on the cold surfaces, on the outboard edges of the insulation.
Wait, you mean with more of a good thing, bad things are going to happen more likely? That's terrible.
Yeah, it's kind of like flying. And we try to, an interesting thing is like flying, which we generally consider very safe. Flying accidents happen because there is generally a systems failure of some kind. It's never one thing going wrong. It's not the pilot did one thing wrong. It's like 5 different things combined to go wrong for the plane crash to happen.
And so the more things you have in the building, the more opportunity they are to interact with each other.
Yeah, in a way, but it also means that when you're putting together the enclosure, we want everything to be done properly, of course, and as the pilot, I don't know if this is the best analogy, but the pilot flying the plane, everything needs to be done by the book to ensure that you're not doing anything too risky. So a lot of assemblies, and we see discussion in various forums where they're saying, oh, well, this assembly's fine or that assembly's fine based on a WFI study or, various things. And it's, well, but what's the risk profile? And is it too risky? And just because it doesn't look like it's going to fail, should we really be riding on the edge? So just because, the pilot can fly the plane asleep, do we really want him to fly the plane asleep? Because we want to build in safety factors, not risk factors. And the Intello is really helpful in building safety factor into these higher insulation level assemblies and giving it greater drying reserves and helping prevent the condensation. So that's a real flagship product, and it's really robust. It has a really strong vapor variability curve. Other things are also vapor variable, like the wood is vapor variable, meaning when it's relatively dry, it's relatively vapor closed. As it gets wetter, the vapor permeability grows until something becomes saturated, then it becomes vapor closed again. But plywood, vapor variable. OSB has a vapor variability to it. But the Intello has been engineered specifically to have a very specific curve and to have a very big curve to it. So going from very quite closed to very open.
Yeah. So as an architect who has worked with Passive House, do you think it's possible to work with conventional building materials that are not engineered to do what you're talking about through the entire assembly and the entire HVAC system?
Right.
When you get such a tight control, because of course a higher performance home or building or whatever it is going to be much more controlled and much more rigid as a result. Can we even use normal building products to do that with, or are they all eventually going to fail because they're just not finely tuned enough?
Well, it's a matter of degree, longevity, quality assurance down the road, basically. One could conceivably do Passive House level construction with off-the-shelf typical components that everyone's familiar with that have been around for a long time. By using components that are of a higher performance level, that are designed specifically for delivering greater air tightness, thermal bridge-free construction, and so forth, and high-efficiency heat recovery, you're basically ensuring the performance at the get-go, because construction, by its nature, has been typically all too unpredictable in terms of what the result is going to be. And as a consequence, all our air conditioning and heating systems are terribly oversized, and there's a lot of inefficiencies in the whole system all the way through. With the careful consideration of the components, and with better components, and then with certified components, what you're getting is quality assurance and predictability. And if you're assembling it correctly with the methodology, which you could use the everyday components as well. But what you're getting is, quality assurance, a robustness that this will work for the longer term, and actually simplifies it down the road. Because to the extent that you don't have to go and do repairs in 10 years or 15 years, to the extent that the systems won't fail further out, you're going to have something that's much easier to maintain, much less costly, and you're going to get paybacks in a whole bunch of different ways. The one thing that's really hard to see, the heat recovery ventilation systems are getting so good that there's, it's hard to see how, you can always do higher performance without having the highest performance heat recovery, but it just adds such a huge benefit in terms of comfort that it kind of becomes apples and oranges. So the trick is, what we would say is, you need to pick and choose very carefully in terms of what you're spending the money on and what the component is. What are the driving factors in terms of the performance of the building, the comfort level of the building, the energy savings of the building. And what we are as a company is focused first and foremost on is air tightness, and not coincidentally, that air tightness is a really foundation of high performance in a building. And so that those things that go together that make and maintain air tightness over the long term are really important to invest in. And we're not talking about, to buy our tapes and membranes and gaskets and whatnot on a typical house. Maybe because you're replacing a lot of materials, maybe you're spending $1,500, $2,000 more, maybe a little bit more than that, but it's in that magnitude. But what you're doing is ensuring that the most fundamental aspect is hit, first of all, in terms of performance, and then maintained over the long term. I'd take an example from the other side, airtight drywall, which grew up in the industry for very logical reasons in terms of an inboard air barrier, which makes tremendous sense from that side of it. But you may hit the blower door number on day one with airtight drywall, but it's going to crack over time. The gaps are going to appear. There are going to be holes in it. There are going to be cuts in it. It's going to fail, and it's going to deteriorate over time. So while airtight drywall may be the most economical and simple material, and you can hit passive house performance with airtight drywall, it's not overall a good investment in a building which we want to have last for 50 years, or longer, hopefully.
Yeah.
We're trying to move that curve.
So aside from becoming code for all buildings in Belgium this year, what is going on with Passive House in the U.S., in New York, and then across the country?
Yeah, it's really exciting to see the uptick in interest. So in New York in particular, which we're most familiar with, as we're based in Brooklyn, New York, as a company, we are... New York City has embraced the idea of reducing the city's carbon emissions 80% by 2050, and the mayor issued a report last September which concretely laid out a clear policy plan. There's a lot of implementation that needs to happen that really saddles the buildings with the largest chunk of carbon reductions for the city. Which is as it should be. The buildings in New York City make up 75% of the carbon emissions, and which is a credit to basically our public transportation system in New York that it's so low. And so consequently, to do that, they are really seriously embracing Passive House as not just as a concept, but in implementing in retrofits of buildings and new construction, and trying to figure out how we can ramp up implementation of Passive House or near Passive House. And so there's ongoing discussions now about mandating certain city buildings to do Passive House construction, big buildings, and then seeing how the code may evolve over the next couple of years to embrace it. So we're at the beginning of the process, but it's on the table, and it's being discussed. 2 days ago, they had the groundbreaking for Cornell Tech on Roosevelt Island. It's a new campus for Cornell University. Mayor de Blasio, former Mayor Bloomberg, and the dean of the school for Cornell, in their opening remarks, all spoke about Passive House, and the mayor about its transformative
he converted.
being. Yeah, no, it's amazing. It's really incredible. I mean, the simplicity of it and the conceptual simplicity of it, and the fact that we're not really inventing any new technology. At this point, it's about execution and training and figuring out how to, scale it. So things are moving along there. We definitely see there have been things written into building codes in Marin County. We see San Francisco Department of City Planning giving certain benefits to projects that will be Passive House certified. We see noises being made in Vancouver about supporting and seeing Passive House go forward there. So it's still, and we're seeing recognition of it by certain governments. But we're still just very much at the beginning, year one, as it were, and. But the recognition and the conversation is starting to happen. So we're hopeful. We see, as a company, we're trying to grow the ecosystem. We see the growth of Passive House as a really powerful and exciting thing. And our product, Passive House, is our low-hanging fruit in terms of selling these products. But at the same time, we see the codes changing for the airtightness and certain other aspects. So the broader market is coming, and hopefully, things will converge. It'll be very exciting.
Awesome.
Yeah.
Ken, thank you so much for being on the show.
Yeah, great. Glad to be with you.
Ken Levenson is the founding partner of 475 High Performance Building Supply and also is with New York Passive House and the North American Passive House Network. You've been listening to the Building Performance Podcast. I'm Corbett Lunsford. Tune in next time. Hey, podcast buddies. It's Corbett. Thanks for hanging out past the music. This is the first time that I've done this. I just wanted to reach out and say that I would love if you would do two things for me. One is if you would rate and review this podcast on iTunes or wherever you get your podcasts. It would mean a lot. We are trying to build this audience from nothing. It's a shoestring budget. I don't know if you know this, but I record these episodes on my iPhone around the country and around the world when I travel, and also on the phone. So thank you for listening to the phone ones too. The second thing that I would love to have you do is if you have a special topic or a special person that you would like to hear more about on this show, I would love to hear from you. So please do feel free to reach out and I will respond. Thanks very much for listening. Tune in next time.